Now let's talk about the type of acids and bases. In 1800, chemical concepts are based on the reactions of aqueous solutions. 7 Arrhenius developed a concept of acids and bases relevant to reactions in water. So, the one which gives the hydrogen ions, they called it as Arrhenius acid. The one which is giving hydroxide ions is called as Arrhenius base. On the other end, we got some other concepts like a Bronsted-Lowry acid, Bronsted-Lowry base, which is nothing but, as I told, your acid will have hydrogen ions. So the guy which donates a hydrogen ion in a reaction, considering this is a reaction, if this is a reaction, the person who is giving hydrogen ion, you can see he gave an ion. The person who is giving an hydrogen ion, that's called as Bronsted-Lowry acid. Who accepts a hydrogen in a reaction is called as Bronsted-Lowry base. The compound formed when a base gains a hydrogen ion then is called conjugate acid. The compound formed when an acid loses a hydrogen ion is called conjugate base. This is referred to as Bronsted theory. Now we'll talk about pH value. The abbreviation of pH is potential of hydrogen. The pH is a measure of acidity or alkalinity of water soluble substances. A change of pH by 1 is of almost 10-fold increase in acid strength or base strength. A pH of 4 is 10 times more acidic than pH of 5. A pH of 12 is 100 times more basic than a pH of 10. So a pH value is a neutral point to identify the acidity and alkalinity, and the value of 7 is considered as a neutral point. The values less than 7 indicates acidity, which increase as the number decrease. So obviously the 1 being the most acidic one here, and the 14 is a more alkaline one here. So the value greater than 7 is a neutral point, less than 7 is acidic, and greater than 7 is alkaline. As I told, the 7 is neutral, less than 7 is acidic, and greater than 7 is alkaline. So this is called as acidic property, and less than 7 indicates the acidic property is increasing. The value decreases, the acidity is increasing. The basic property, the value increases, the basic property will increase. So these are the common substances which we are using in the regular life. As I told, the 7 is acidic, so neutral, and this one is acidic. So HCl, this is more acidic, and here sodium hydroxide is more acidic here. These are the intermediate items which you are using in your normal life. Reaction with indicators. What is the indicator? Indicator is a substance that gives a visible sign by a color change. Maybe the presence or absence of a threshold concentration. Maybe an addition of acid or alkali. A typical example is methyl yellow, as indicates it's a yellow color, which imparts a yellow color to an alkaline solution. There are typical indicators available in normal. So phenolphthalein, If it is react with acid, it's colorless. With the base, it's dark pink. If it is neutral, it's a faint pink. Bronchimol blue, which is really blue color with the base, and in neutral it's green, and if it is acid, it's yellow. For litmus, it will react as a red color with acid and blue color with the base. So we are talking about the pH paper. pH paper, the other name is litmus paper. It's a filter paper that is treated with natural water, soluble dye from lichens. pH paper changes colors to indicate a specific pH value. Whereas buffer is a solution that resists changes in pH when small amounts of acid and bases are added. It will restrict any changes in the solution. That's your buffer. We'll talk about the chemical properties of alkali. Alkalis are used to produce the insoluble hydroxide precipitates of many metal ions from their soluble salt solutions. You can see sodium hydroxide, which reacts with copper sulfate, which forms sodium sulfate and copper hydroxide. So basically your copper reacts with hydroxide to form copper hydroxide.